So let's have a look at question 69. I'm going to write my domain and range, just so that I can identify what I've got. So what do we notice with our domain and range? We're limited for our f of x function that it has to be between -1 and 1. Okay. Square root function. So if x is -1, our y value is going to be 0. When x is 0, our y value there is going to be 1. Okay. So our range of our function is going to be between 0 and 1. When I have a look at my domain of my g of x, my domain is a set of real numbers. Okay, and the fact that I'm squaring this number means that I'm always adding something to 2. So my g of x here is always going to be 2 plus something. So my g of x range is going to be 2 to infinity. So I've written that down so I have a good idea of what they are. I've been asked here in part A to work out my f of g of x. So that means that my range of g has to be a subset or equal to the domain of my f function. So let's have a look. What do we have? My range of g range is going to be 2 to infinity. So I'm looking at this. And that has to be a subset of the domain of my f function, which is this. Well, that's not the case. So that's not the case. So therefore, f of g of x, my composite function, does not exist. And if that doesn't exist, then we can't get the gradient. Doesn't exist. So let's check the conditions for the next one. So for part B, we've got g of f of x. We need to work that out. So that means for that to exist, the range of f has to be a subset of the domain of g. Range of f has to be part of the domain of g. So we're going to write that down and say 0 to 1 has to be a subset of the set of real numbers. So therefore, g of f of x exists. So I'm going to write down what g of f of x is. Okay, we're saying I have my g of x, so it's 2 plus. In place of x squared, I'm going to put the square root of 1 minus x squared squared. So expanding that's going to give me 2 plus 1 minus x squared. So I'm going to have 3 minus x squared. So now I can continue with that and get my g of f of x dash with respect to x. So it's this composite function with respect to x I'm getting the gradient for. So that means my gradient from the above is going to be equal to minus 2x. So that then allows me to work out the question that I've been asked to work out. And it is a value of 3, which of course is going to be minus 6. Now, we'll do that, and we've gone through that whole process, and we think that that's fantastic. We've worked through what our function is. But let's have another look at that. Okay, our domain of our g of x, right, so our domain of our composite function, so the domain of g of f of x, okay, is equal to the domain of f. And when we check our domain of f, we notice that our domain of f is between -1 and 1. Okay, so our domain of our composite function is equal to the domain of what we are putting inside there. But our x value that we've been asked to solve for here is outside the domain of -1 and 1. Okay, so therefore, g of f of x dash of 3 doesn't exist. Now you might say, oh look, this is, that's a lot of work to make sure that we're saying that it doesn't exist. But the whole concept here with regards to composite functions is we remember that because we've been doing functions and relations before. So we identify, as I have up here, identify the domain and the range of each one of those functions. Before you do anything further, before you work out whether you can get the derivative, whether you can do the substitution, you check the range of whatever you are putting inside that function is a subset of the domain of that overall function. You notice with part A, it doesn't exist. Therefore, we didn't solve this. We started on part B and the red said, well, yes, you know what? The range of f, 0, 1, is part of the real number system. Therefore, it exists. Great, fantastic. At this point in here where it's red, if we recognized at this point that for this particular function, the domain of that function has to be part of the domain of f, then all of this in black would be unnecessary to do. Okay, so the idea is make sure that you have that written down and you do those two checks. Does it exist? And then what are you substituting in? Is that value there part of the domain of what you're putting inside your composite function? Otherwise, what we've done is we've said, yes, it exists. Here's my answer. And we walk away without checking this feature here. Okay, so that's really, really important to double check that feature. So please highlight the importance. Okay,